So it's my pleasure to introduce Kelly Bubp from Ohio University. She's going to be talking about an evaluation of selected notes from the Journal of Inquiry-Based Learning in Mathematics.
All right, well, good afternoon, everyone. Thank you very much for coming. So I am going to be talking today about basically a curriculum evaluation project that I'm working on with respect to improving at the undergraduate level. So proof is an essential part of doing mathematics. I believe Ed Parker said yesterday that it was the heart of mathematics. Alan Schoenfeld calls it the soul of mathematics. So there's a lot out there about how important proof and proving is to mathematics. Unfortunately, maybe unfortunately, I don't know, it gives us something to work on. A lot of undergraduate students really have a lot of difficulties with many aspects of writing proofs and the proving process in general. So we have a lot of work to do in trying to help undergraduate students and all students, of course, become more understanding and more competent in proof and proving. And so we really want to be able to focus explicitly on helping students improve in these areas. So there's a lot of attention to a proof itself and the very formal aspects of the proving process. But when you actually think about really what all goes into the proving process, especially if you're a research mathematician, there's a lot more than just the formal aspects of writing up the proof, the end product of this whole process that involves an awful lot of exploration and conjecturing and refining things and testing things and doing all of this extra stuff that doesn't necessarily fall into the category of formal logical mathematics. And so I really want us to think about this broader range of activities that are related to proof beyond just the formal aspects and the broader types of reasoning that we need to employ when going through the proving process, including both intuitive and informal reasoning in addition to the formal reasoning. So this curriculum evaluation project that I'm working on, so the first part was basically developing a set of proof and proving standards that could be used as a framework for evaluating curricula. And I put these together based on recommendations from AMATIC and CUPM, as well as just looking at the general research literature on proof and proving at the undergraduate level. So there was a lot of literature that I looked at that went into developing these standards. And so then the next phase, which I'm really going to talk more about today, is really seeing how these standards actually work for evaluating curriculum and if they really are getting at different aspects of what the curriculum offers as far as opportunities for students to engage in a wide variety of reasoning and a wide variety of activities relating to the proving process. And so right now I'm really just at a very holistic sort of testing phase and looking at how these standards work on some curriculum. And I'm really looking only at this point at written curriculum. So we all know that a lot can change when you're actually in the classroom. So what I'm doing here doesn't really take into account any of the changes that would go into actually implementing a curriculum in the classroom. They're really just focused on the written curriculum as it appears in a text. And then after I do this whole testing refining phase, I will do a more wide-scale curriculum evaluation with the standards. So this is just a sort of a quick overview of the standards, and you'll get a chance to look at these in more detail in a couple minutes. So basically, Standard 1 is looking at more of the intuitive and informal aspects of the proving process. Standard 2 is looking at communication aspects. Standard 3 is more of the formal aspects related to definitions, proof structures, logical reasoning. Standard 4 is the opportunity to actually construct proofs and counterexamples. And then Standard 5 is looking at this appreciation of what proof is, what role it plays, and how important it really is to mathematics. And because I am looking only at written curriculum, I'm not going to talk about Standard 5 today. It's really difficult to kind of get at those aspects just from written curriculum. So I am going to focus, though, on the first 4 standards. For the sake of this presentation, I've actually done an evaluation of published notes in the Journal of Inquiry-Based Learning in Mathematics. I looked at 5 sets of notes. There's 3 on real analysis and 2 on abstract algebra. So I wanted to look at notes in advanced mathematics courses that are very typical core courses for the mathematics major. And at a lot of universities that I'm familiar with, unfortunately, there is no Intro to Proofs course. And so we get a lot of students that are coming into either a real analysis or an abstract algebra course who have never taken a proof-based course before. So I do think it's important that these course notes and these textbooks for these types of courses can possibly accommodate students that are really learning proof for the first time in these courses. So these next few slides, just so you know, so the top part is a more detailed statement of the standard itself, and then the bottom part is, again, sort of a holistic view of these 5 sets of course notes that I evaluated. And so, again, standard 1 is really looking at more of the intuitive and informal aspects of proof relating to exploration and conjecturing and generalizing and example-based reasoning, these kinds of things. So of the 5 curricula that I evaluated, I did find opportunities for students to both construct and evaluate conjectures and generalizations, apply definitions and theorems to either specific or general examples, and there were opportunities for students who were given an object or an example and were asked to determine if it had certain properties or if it was an example or a non-example of certain definitions. On the other hand, there were opportunities for students to actually construct an example or a non-example having certain properties or fitting certain definitions. However, although there was a wide variety of opportunities to involve or engage in these intuitive and informal aspects of reasoning, they were really very few and far between in the notes that I evaluated. Many of these opportunities occurred either in just one curriculum only, or in the other curricula, there was only a handful of these types of problems in, a set of 100 or so different problems within the course notes. So one particular curriculum by Morrow, 2012, this was abstract algebra curriculum, did include really consistent opportunities for students to engage in example-based reasoning and dealing with uncertainty related to conjectures. However, many of the other curricula really had very, very limited opportunities for students to engage in example-based reasoning, especially when it asked them to construct their own examples, or again, and I don't think there was maybe 1 or 2 problems in 4 other curricula that really offered students the opportunity to engage with uncertainty. So standard 2, which deals with communication, not surprisingly, there were many, many opportunities in all of the course notes for students to deal with communication and work on their precision with their language and notation. And again, because these were, more method inquiry-based notes. And so a lot of this I looked at the instructor's version of the notes, and so even though the notes themselves didn't necessarily, scream, we have opportunities for communication, in the instructor's description of things that go on in the classroom and that kind of stuff, they talked about all of the, consistent opportunities for presentations, and the fact that in the typical classroom, there's going to be a discussion and critiques going on of the presentation, so that there's a lot of communication back and forth about the mathematics. Most of the notes included that the instructors typically require their students to write and turn in proofs in addition to just presenting them. And I think that's also seems to be very typical of a lot of the things I hear from the way people are running their IBL courses. And there was one curriculum in particular that actually asked students to rewrite statements in alternative notation, so to translate from words into logical symbols and that kind of thing, to work with more of the notational aspects. So standard 3 is more on the logical aspects of reasoning, so looking at definitions and proof structures, that kind of thing. And so, again, not surprisingly in these notes, of course, there are no written proofs for students to analyze, but you do have the fact that students are consistently presenting proofs in class and do have the opportunity to consistently analyze the logical reasoning, the way that comes into play in the proofs, the way definitions come into play, and the way the proof structures work in constructing these proofs. So they can do this, of course, with their own proofs that they're constructing or the proofs that their classmates are presenting. And there was some work with examining the effects of weakening hypotheses, but again, this was very weak. There was very little work with modifying hypotheses and conclusions, and therefore, so when you have little work with conjecturing, you have little work with sort of modifying conjectures. And then there was some opportunities for students to construct analogous definitions or theorems to ones that were given. So for example, if you were given a definition for a lower bound, then construct an analogous definition for an upper bound, that kind of thing. So standard 4 is the actual construction of logical proofs and counterexamples and being able to identify invalid reasoning in proofs. And again, within this structure of an IBL course, students had consistent opportunities to actually construct their own proofs. No big surprise there. And then in the discussion portion to identify invalid reasoning and proofs as well. So that was really great. On the downside, though, there was really very, very few opportunities for students to construct counterexamples or refute statements. So again, the same abstract algebra curriculum was the only one that really dealt with these uncertain aspects where that students had to prove or disprove statements, where they were not presented with statements that were just assumed to be true. And so again, there was like 1 or 2 problems throughout the whole 4 other curricula that offered students any opportunity to really think about the truth value of a given statement. And not only was there not, prove or disprove type statements, there also were no statements where it just said, provide a counterexample for this. So there was very, very little opportunity to work with counterexamples and refuting statements. So in summary, so students really had a lot of really significant opportunities to engage in a lot of aspects of the standards, including specifically looking at communication aspects, using precise language, notation, and symbols, comprehending and critiquing both spoken and written reasoning and proofs. I'm sorry, spoken reasoning and proofs in particular. There wasn't really a lot said about the written aspects. Constructing proofs, of course, and identifying invalid reasoning through the communication aspects in the discussion in class. However, then the sort of the limited opportunities that these curricula posed for students were issues with uncertainty, so deciding on the truth value of mathematical statements, opportunities to either explore or construct examples or non-examples of definitions, again, constructing counterexamples and refuting statements, and then back to this issue where you don't have a lot of conjectures, you don't get the opportunity to refine them, so you don't have a lot of work with modifying hypotheses or conclusions. So just some general recommendations for textbooks, writing in general, or course note writing. Since we don't know, again, how these are going to be implemented in the classroom, but I think that when we do put our course notes and our textbooks in print, we really want to provide as many opportunities as possible for all aspects of reasoning to be addressed for whoever happens to pick up those course notes or that textbook and try to implement it in the classroom. So just some things to consider would be including tasks that really ask students to examine or construct examples and non-examples after a definition is given. Asking students to provide counterexamples. So again, you can do this just including tasks that say provide a counterexample if you don't want to have the actual uncertainty so they know it's false, they know what they have to do. Or you can move to approve or disprove type directions for a statement. So not only do they have to determine if they think it's true or false, but then they have to move forward with that and either construct a proof or try to find a counterexample. Or if you want to go one step further, you can look at directions such as prove and extend or disprove and salvage. So then that includes if you have a statement that actually ends up being true, that you would then have to modify it, right, to generalize it more, something along those lines. Or if you have something that is false, you not only have to construct a counterexample, but then again, you have to change things up a little bit to make it true, and then construct a proof as well. So you get a whole variety of reasoning involved in those types of problems. So that's all. Thank you very much.
So we have 5 minutes for questions, and I'm asking people to come to the microphone to pose those questions.
So in the evaluation you looked at, did you actually look at each of the theorems where it said prove, and then find if some of them were purposefully, intentionally false?
I did not look
because
for
I know
that.
Ted Mahavier throws those in his work.
Yeah.
And so that would mean, and there's some of that part in there, but the students don't know.
That's true. So you're right. There may be some hidden
Okay.
aspects of uncertainty that I didn't look at. I didn't get to quite yet. I've not done a very detailed, quantitative analysis of anything yet. So this, like I said, is a very preliminary, very holistic evaluation thus far. But thank you for that. I'll have to look for that.
It's a very interesting talk.
Thank you.
I would just like to add one suggestion to your
Sure.
suggestions,
Absolutely.
at least to consider. If proving theorems, something like it's like climbing a mountain. We've been doing a lot of metaphors this meeting.
Mm-hmm.
It's like climbing a mountain, and you have to have the right equipment. You have to step in the right places and not step in the wrong places, and so on. And it might be interesting to find out whether you can climb that mountain. But I think a crucial part of what should be in these books, and is in some of them, is you have to want to climb the mountain. And the book has to give that to the student, and the student must really want to know what the answer is and not just carry out the thing. And some of the books do that and some don't. It would be good, I think, to distinguish them.
Great. Thank you very much.
This is the first time I've heard anybody talking about what makes successful inquiry-based notes successful. And so this is really interesting for me because I've also tried to write materials. So I wondered if you're doing anything further to sort of understand what is it about successful notes that makes them good.
At this point, I'm not. Like I said, the focus was really on creating the standards to begin with, just trying to see, because the original focus was more, what all kinds of things go into this whole proving process, and what is it that we're lacking when we really sort of emphasize the end product, the proof itself. And then it sort of turned into this idea of really looking at these notes and how they might address all of these aspects and really provide students with a wide variety of opportunities to engage in a variety of reasoning. And so beyond just evaluating, again, refining the standards and really evaluating more textbooks, I don't have anything else planned. So if you have any, suggestions or anything that you think would be really interesting, that would be fantastic.
And I guess my follow-up is, have you been looking also at traditional textbooks the same way?
I'm going to. I haven't yet. Again, this is very, very early in the evaluation stages, but absolutely, yeah, traditional textbooks are going to be
That's going to be very frustrating for her to look at.
It will be, and yeah, so I wanted to start with the IBL stuff because I was really, I expected that I would find a lot more opportunities in these than I will find in the traditional textbooks. Mm-hmm. But I mean, there are good textbooks out there, I'm sure.
We have time for one quick question, last quick question. Okay. So thank you very much. Thank you for coming.